Welcome to this video on Maths with Adi, where you have access to mathematical courses, and we are doing algebra course, and we are in the middle of algebra course. We have successfully completed exponents, okay? And if you know about exponents, then the links to those videos are in the description. You can check them out. Today's topic is polynomials, okay? So before going in depth into polynomials, the book that I use, okay, the textbook that I use for this algebra course is this, Sullivan Algebra, okay, by Michael Sullivan, okay, the 9th edition. So it is Sullivan Algebra and Trigonometry, okay, so there is also the trigonometry, but I'm not gonna do the trigonometry course in this series. I'll do the trigonometry course from this book in another series, okay. We are doing algebra course, okay. So if you have this book, good, but if you don't have this book, these videos still will be beneficial for you, okay, because most of the contents will match. So today's topic, polynomials. So what are polynomials? So if you understand the etymological meaning, then most of this is clear, okay, most of this is clear, because even the etymological meaning won't tell you the whole picture, okay. So it comes from two words, poly and nomials, okay, nomial, okay. So what do these words mean? Poly means many, and nomial means terms or parts. So you have many terms or parts, okay? But this is not its complete meaning. Let me elaborate, okay? This is not its complete meaning. Some people would say, okay, polynomials are only many terms, then it's not, okay? For example, let me give an example of polynomial. 2x plus 5 is a polynomial. 3x plus 6 is a polynomial. We have two terms here. These are two terms, and we're going to talk about the meaning of term as well, okay? But this is not its complete meaning. Only many terms are not polynomial. Polynomials can be with only one term also. For example, if you have just, let's say, 6x, this is also a polynomial, okay? And this is known as a monomial, okay? If you have just a number like 5, this is also a polynomial. This is also known as monomial, okay? And that was its etymological meaning. Now let's talk about the real meaning, okay? What is polynomial then? What is real meaning? Okay, so I'm not going to write the textbook definition, because definitions are not helpful at all. You need to understand the concept, okay? So expressions in the form like a sub n times x to the power n plus times x to the power n minus 1 plus so 1 plus. Okay, so this is the general form of a polynomial. Okay, so what does it mean? What does this indicate? First of all, this is the variable. Okay, so you already are familiar with variables. If you're not, check out my videos. Check out the videos. Okay, so this is a variable x in 2x. This part is the variable, and this is known as the coefficient. Okay, coefficient. Okay, so this is also here the coefficient. This is the variable. Coefficient part, variable part. Coefficient part, variable part, and this is only a number, okay, constant. Okay, so this is our n power, the x to the power n. This is x to the power n minus 1. So you can see that this exponent is decreasing. Exponents are decreasing, meaning there is a order of writing polynomials, and that order is decreasing order. Okay. For example, x to the power 4 plus, if you have x, let's say 2x cubed plus 2x squared plus 5. Then here, as in this example, as you can see that there is a decreasing degree of monomials, okay, and that is its order, meaning its power is 4, its power is 3, and its power is 2, and its power is basically 0, and that is decreasing. It's decreasing. So the order of writing a polynomial is this decreasing degree of monomial. Okay, right now you just understand its power if you're not getting degree, okay, because that's also will be the partial truth, okay. We're going to talk about degree also. Okay, so let's have a look at this. That's the general form. This is the general form of a polynomial. And what does this say? This is a variable with an nth power. This is a variable with n minus 1 power, meaning that is increasing, meaning its exponent is decreasing. Okay, and after decreasing, we come where its exponent becomes 1. Okay, the exponent of the variable becomes 1, and we also come to the end, meaning when its exponent becomes 0 and becomes just a number 1. Okay, so you can see its exponent is decreasing. And is this decreasing at the constant? Then not. We are just writing this to differentiate between the coefficients, between constants. Okay, so this indicates a constant. Okay, so a sub n minus 1, and a sub 1, even a sub 0, these are constants. These are constants. Okay, these are constants, also known as coefficients of the variables. Okay, of the variables, and these are constants. This is for just the notational purpose. Okay, there's not any special meaning being conveyed that it's something is decreasing. It's not. It's only for differentiating between the coefficients. Okay, and here the exponents are decreasing. Okay, if you still is not clear, by some examples it would be. Okay, it will be clear soon. Okay, let's move on to the next topic. What do you have next? What are terms? Okay, so before understanding polynomials completely, we need to be familiar with the terms. Okay, so I've already told you the meaning of polynomials. If you're gonna, watch that again, you can skip to that part. Okay, so terms are basically single identity. Single identity. When you have, in which you can have multiplication between between a variable, multiplication between a variable, let's write it here, a variable and a constant, okay, in which you have a multiplication between a variable and constant. Okay, for example, 2x, it's a term in itself. Why? Because you have a constant here multiplied to a variable. Okay, and that is known as a term. Okay, it's a term. Some people would say, what about 3? Is this a term? Yes, it is a term. Some might wonder that there is only the number, okay, the constant. There isn't any variable there. Then there is a variable. And what is that variable? You can think of that variable as x to the power 0. Okay, any variable you like it, y to the power 0 or whatever. Okay, so you have the variable there. So if you want to write its complete meaning of the term, then I should write also multiplication between constants. Okay, so it can also be just a multiplication between constants. For example, 2, it's 2 times 1. Okay, and it is what term? If you have just a number, that's a term. Okay, like 5, it's a term. 2x is a term. X plus 5, there are 2 terms there, but if you talk about one term, x, just x is a term. Okay, so this is what a term is. A polynomial means many terms. Even one term is a polynomial. It's a special kind of polynomial, which is known as a monomial if you have just one term. Okay, if you have many terms, there are names for those as well, in which we learn in classification. Okay, so I hope polynomials are clear now. Let's give some examples, more examples of polynomials. The examples that I've noted are, let's say, minus 8x cubed plus 4x squared minus 6x plus 2. That's a polynomial. How many terms there are? In this polynomial? 1, 2, 3, 4. There are 4 terms there. Okay, let me just write the terms as well. There are 4 terms. Okay, Another example I want to give is 4x to the power 4th plus 5x cubed minus 6x plus 2. That is also a polynomial. How many terms? How many terms you see? 2 to 4. Again, 4 terms there. Okay, you see 4 terms. Another example would be 5x squared y. Okay, so here I have just written with one variable. It can be with multiple variables. Okay, there can be multiple variables. For example, sorry, z here. Okay, that is a polynomial. Okay, how many terms do you have? 3 terms. Okay, terms are 3. Okay, so that's a polynomial. Okay, even 3x, that's a polynomial. 4x, that's a polynomial. X, y, z. Okay, you can have multiple variables there. That's a polynomial. Number like 5 is a polynomial. 3 is a polynomial. So these are examples of polynomials, and by now it should be clear what are polynomials. Let's move on to next thing, and that is there's a condition. The condition that is exponent of the expression should not be a fractional part or smaller than 0 to be a polynomial. Okay, meaning there are some expressions which are not polynomial. Okay, so what are some expressions that are not polynomials? Okay, so not polynomials. Okay, so should I add in capital? Yes. Okay, so what are not polynomials? What are not polynomials? We have something like 1 over x cubed plus 4 over x squared plus 5 over 3x plus 2. This is not a polynomial. Some people would say that this is, some people might wonder if you're just a new or beginner. When this is a whole number, how come this would not be a polynomial? Then this is not, okay, this is not a polynomial. How come? Because it is x to the power minus 3. If you write this in terms of exponents, okay, this is as that, and this part here is 4 times x to the power minus 2, and this here is 5 times 3 to the power minus 1 times x to the power minus 1 plus 2. Okay, and you can see how many negative exponents are there. There are plenty of them, and it's not a polynomial because of that. Okay, only one negative exponent makes the whole thing a non-polynomial. Okay, this is not a polynomial right over here. Let's give you another example. Okay, I'll give you another example. But there are plenty of minus in exponents. Okay, negative signs in exponents. X y to the power minus 1 plus 4x plus 6. Okay, this is also not a polynomial. Why? As you can see, this is crystal clear. So this is not a polynomial. It's crystal clear. As you can see, a negative power. Okay, let me give you another example. X to the power root 2, say y, plus 2yz. Let's find a number 16. Okay. Now, this again not a polynomial. Why? Because as you can see, again, this is a fractional part in decimal. Okay, root 2 comes out to be in decimal. It's a rational number. Okay, and this what makes it a non-polynomial. Okay, this is not a polynomial. Another example would be root xyz plus z here z root y plus x plus 6. Okay, again this is not a polynomial. How come you have this, the root, okay, square root over x, y, z, and this is what it makes it a non-polynomial, because its power is half. Okay, I'm sorry, the whole power of x, y, z, okay, of this whole, okay, is half. Okay, so the power of this whole x, y, z is half, and it's a fractional part. It's not a whole number. That's why it's not a polynomial. Okay, so these are some examples of non-polynomial expressions.